Hi, I'd like to send a warm welcome to all of our partners, clients, colleagues, and friends across the building industry. My name is Stephen Montgomery, Sustainable Construction Advisor in PCL's Toronto office. I'm happy to host this roundtable discussion about building retrofit and particularly the Passive House EnerPHit program and the challenges that it represents to contractors and trades. Staying firmly in our wheelhouse as general contractors today, we've assembled our own team that were responsible for assembling the processes that got us to the finish line successfully. We'll share a bit of our excitement about that project, but what we also want to share is the general notion that these projects that are high performing and low carbon are achievable in today's market, and that there's something that PCL is proud to be a part of. Building retrofit has been identified as one of the key instruments to draw down carbon nationally, and as always, proper planning for cost, time, and procurement are the path to quality and consistency. But as many of people in our audience will know that those are just words until you get into the details of those processes and how they need to be changed to make these sorts of things happen. Through the sharing of stories and the lessons learned on these projects, we hope to sort of share with the industry some of the tools that we've used to ensure that we get to these project finish lines successfully. After some introductions, we'll start with some general questions about Passive House, and then we'll move on to specific Sobel projects. We'll then cap it off with some Q&A. So let's get started. I'd like to welcome to the table Project Superintendent Andrew van der Straten, Project Manager Jonathan Rodriguez, and last but not least, our Envelope Specialist, Lori O'Malley. Welcome, everyone. And we'll begin with a brief introduction from each of you.
Hi, my name is Andrew van der Straten. I'm superintendent. I've been with PCL 19 years. PCL has provided me the opportunity to be involved in a number of challenging and interesting projects like this one. At Sobel project, I took on the role of Air Boss, which I'll talk about later.
Hi, my name is Jonathan Rodriguez. I'm a project manager with PCL. I've been with PCL for 12 years, and over that course, I've had the opportunity to work on many industry-first, unique projects. Soble Tower is another unique project and a first for us at PCL, and I'd love to share my experience with you.
Hi, my name is Lori O'Malley. I've got over 24 years of building envelope experience. I joined PCL in 2008 as a building envelope engineering specialist. Prior to that, I worked as an associate responsible for the building envelope group at a large consulting engineering firm here in Toronto. I've had the good fortune of being able to work on a number of projects with PCL across North America. I'm very lucky to be able to work on several high-performing building envelope projects, including the Sobel project. I strongly believe that high-performing building envelopes are going to be required on all of our projects moving forward because of the demand from society and the environment. I also believe that enhanced measurement and verification is necessary in order for us to confirm that the products we are actually supplying meet the performance requirements of the project. I'd actually like to look back at some of Canada's history and point out that energy efficiency is not new. Back in the early 1970s, a gentleman by the name of Harold Orr, an engineer located in Saskatoon, actually pioneered high-efficiency building envelopes by constructing the Saskatchewan Conservation House. His efforts on his high-performance project inspired the birth of Passive House in Europe and led the way for a new global awareness regarding energy efficiency in buildings. His efforts actually resulted in him being awarded the Order of Canada for his contributions to the construction industry. And I'm happy to see that in Canada, we're continuing on with his efforts by trying to provide more and more energy efficient building envelopes.
Yeah, no kidding. PCL, we were all quite familiar with coming out of Saskatchewan with some pretty good building innovation ideas. So we should really be right at home with this.
Oh, definitely, definitely. Passive House projects really demand that a high level of quality, of comfort, be provided for the occupants with a very low energy consumption. So what they've done is they've actually developed 5 fundamental principles that we have to follow in all of our projects. The first principle is that we have to provide a high level of insulation on all our exterior walls, specifically the opaque wall areas and the roof areas. We then have to provide very well insulated glazing systems. We also have to provide a thermal bridge-free design and construction, followed by an airtight building envelope, and last but not least, providing ventilation with highly efficient energy and heat recovery systems. Passive House certification also allows for the owners to obtain confirmation that what they actually bought is what was actually constructed, and that their finished product actually meets the performance requirements for the project. So for us as contractors to be able to achieve these goals, we really have to return back to our fundamental best practices for contractors and look at things such as being able to review the design details and documents to make sure they are actually constructible, and that we can actually provide a continuous, the continuity of all of our control layers, as well as we need to be able to define the scopes very clearly so that all of the performance requirements are clearly outlined for all the parties. We also need to obviously create and develop a budget that can be used throughout the entire project. And we need to be able to develop a construction schedule and come up with a sequence of work that allows us for actually to build the building envelope systems to create the necessary continuity of the control layers. And probably the most important point of all is that we need to be able to develop and undertake a quality program that allows us to confirm throughout the entire project, from the start of the project all the way to the end of the project, that we're able to build a building envelope that meets the performance requirements. And we need to be able to measure and verify the effectiveness of our build at every step along the way of the process. Although it sounds rigorous, constructing a project using the Passive House standards is attainable. And it's not only attainable for those projects. In my opinion, we can actually apply them to all of our new construction projects as well and our revitalization projects. If we follow these principles, we can not only achieve the technical requirements of Passive House, but we can also build both new projects and revitalization projects that are resilient, durable, simple, and affordable throughout the entire life of the project.
That's an exciting bit of news given the demand that we've got coming at us for those types of buildings in the future. But taking it out of a list that sounds good and concise, you can tell there's a lot of details and a lot of information flowing on a project like this. So that's where Jonathan's going to come in. How did that affect your role, and what did you put in place to help deal with some of these details and finer points and reporting and testing that had to take place during the project?
Well, as Laurie mentioned, the 5 key principles are definitely front and center in all discussions and decisions that we make. But to really set up the project for success is we got to tackle it early on with a team approach. And what I mean by that is we got the ownership, the consultants, sub-consultants, the contractor, and as many of our trade partners as possible to join us in as early as possible. So ideally, I'd say pre-construction when we're still developing the design. That allows us to, as a team, mutually agree on the budget, schedule, and come up with performance and design goals together that's achievable.
It sounds like we're really going back at the integrated project delivery that we've been talking about for a lot of years in construction, but really trying to make it a meaningful conversation where we're getting down to brass tacks and getting down to brass tacks at the right time. Was this a management level review, or was the detail a little bit deeper than that? Everyone coming down into a little bit more resolution?
Yeah, it was. We definitely have to dive into detail. We take the holistic approach from the whole team. When we talk about integration, we take construction design. We bring on as many trade partners as we can, review the details. If it's a penetration detail, we bring in the envelope, we bring in the M&E trades, and we kind of review everyone's responsibility on a simple detail, and we look at it as a whole, that everyone is responsible to ensure that we meet Passive House. So it's not a singular point.
Excellent. So in a design assist role, then we can sort of gain that deeper understanding. We can have those kinds of conversations that make the integrated project delivery what it was always supposed to be, and that's good for meeting standards like this. The team approach really sounds like was the way to go.
Yeah, and as a design assist contractor, we can ensure that we're tracking the design from construction right to the end through shop drawing submittals, QA/QC. Activities and validating the design through construction as well. And taking that team approach really starts at design and continues through construction. And we need to be flexible as a team, especially on a retrofit, to handle any problems that arise and be flexible that way.
So Laurie, we've been facing this sort of thing for quite some time. We've seen it a little bit within certain criteria in LEED. We see it a little bit in TGS, and we'll be seeing more of it in the coming years as they increase the requirements for it. How has this affected our process? What have we learned to reinforce?
I'm happy you asked that question, actually. As an industry, our buildings are becoming more and more energy efficient, more and more resilient, and more durable. Lower glass-to-wall ratios, higher performing glazing systems, higher thermal resistance in our opaque wall areas, minimizing thermal bridges, and improved air tightness are all conversations that are taking place very early on in our construction projects. And I'm happy to say it's not just the Passive House projects that are having these conversations.
Yeah, it's a good point, and we've noted some of that in the earlier years of LEED, and how we notice something, we experience a success and quality that comes from a focus on a certain part of the scope, and we bring that forward to all of our jobs. What is it we're looking to gain from the conversation with designers early on to feed this process?
Yeah, as a contractor, we really have to work with the project team to help develop constructible details that will provide the necessary continuity of the control layers and then really turn them into reality.
Yeah, and am I right to assume then that as we're going through those with the designers, we're then also able to draw in discussion and planning for how we're going to measure and verify that?
Definitely. We found over the years that enhanced verification is becoming more and more common on our projects, and a detailed quality plan is essential in those processes. Having a plan that allows for this confirmation to occur at a very early stage in the project, or as early as possible in the project, is really essential in order for us to be able to avoid the need for some rework. Using out a really well thought out construction plan and a quality plan allows the project to be on time, on budget, and meet the quality standards for the project. In my opinion, the use of Passive House projects or other similar certification systems that are out there is becoming more and more standard on our projects, and I'm happy to see that that's going to soon become, hopefully, the standard level of practice for us.
Absolutely, and that's really exciting. I think we've really nailed down the need for that early, robust conversation, and not just saying the words, but finding the topics and driving them in the conversations and making sure we have the right people there to push those conversations and make those plans. Right down to the nuts and bolts, and with the envelope right down to the blue skin. Lori, let's just dig in a little bit deeper into those conversations with the design teams, and what the key highlights or the key risk areas that we're sort of narrowing in on when it comes to a Passive House project.
Oh, definitely. In most instances, the actual building envelope assemblies themselves, so the systems proper being provided to us by the subcontractors, have a fairly well-known level of performance, and the subcontractors themselves are quite efficient in installing those. It's in fact the transitions between those specific systems and the adjacent systems that represents the biggest risk for us on project. Transitions mean, for example, the connection between the opaque wall system and the glazing system, or from the roof system to the opaque wall system. It also includes penetrations where you might have, for example, a conduit or a duct or a pipe, or even structural steel running through the building envelope systems. All those have a higher risk for potentially having performance issues in the future. So it's really important that each of these transitions are carefully reviewed during the design, the submittal, and the construction phases to make sure that we get the necessary continuity, and that we also confirm that the materials that are being used by our trades are actually compatible and they'll adhere to each other in order to obtain the necessary level of performance with them. We also really need to make sure that we coordinate each of these packages properly to make sure that we get the necessary continuity and everybody understands the sequence of work and how they need to be installed to get the continuity that's needed. As evidenced by the success of this project, the Ken Sobel team definitely understood the importance of monitoring and coordinating each of these transition details.
Well, as a mechanical electrical coordinator, I have to say that the thought of managing and keeping an eye on every single conduit and pipe that goes through the envelope is a daunting task. So no doubt that early planning and discussion and process development is critical. You mentioned the Ken Sobel project, so I guess we'll open that up now. I know we've kept you all waiting. But let's talk about the Ken Sobel Tower and just dig a bit deeper into how it affected our processes and what we learned there. Jonathan, maybe you can kick us off by just giving us an overall view of the Ken Sobel project and the vision that was behind it.
So Ken Soble Tower is an 18-story high-rise multi-residential building in Hamilton. It was actually originally built in 1967 and was selected by the city of Hamilton to undergo a Passive House retrofit. With this Passive retrofit, it will be one of the first in North America, and it will also be one of the largest EnerPHit projects in the world.
All right. That's incredible. What were the key drivers for this client that made Passive House attractive to them?
Well, the retrofit focuses on efficiencies and low operating cost. This was achieved through a number of design initiatives, but really focused around extremely high-performing cladding system, focused on air tightness and eliminating pre-existing thermal bridges, such as like the balcony slabs that the building originally had. The design also reduces greenhouse gases by 94%, and at its peak, the total energy required to heat or cool one of these units will be equivalent to 3 incandescent light bulbs.
This is an incredible feat. A 94% reduction is the kind of reductions that we're talking about if we're going to meet the kind of commitments that Canada has made internationally to draw down carbon, particularly on the existing building stock. We've spoken a good deal then about defining a more detailed team discussion, a more real experience of the integrated project delivery. Let's open it up to the table then and see if we can capture some of the schedule, scope, and procurement highlights that we changed. Starting with you, Jonathan, compared to a typical tower, what kind of exercises did we get into on those 3 fronts?
Well, compared to a typical tower, the risks are very similar. Schedule and budget are still the biggest that we have to deal with. Passive House just adds another layer to that. And for instance, for the budget, we need commitment from the owner. Passive House construction has a higher upfront cost to build. And it's really driven by the material that's out there. So right now, the material selection for Passive House is pretty limited. And on a typical job, the materials that we use in Passive House, we'd refer to as premium products. So to keep that in mind, we have to really be mindful of our selection and how that affects the rest of the job.
Excellent. So right away we can see the budget concerns and a little bit of the procurement concern. How about schedule?
So schedule is related, again, a big part to material. A big part of the Passive House model is exterior improvements. And that's where the material, you really need to be mindful on the material selection for time of year because we have temperature limitations. Products like air barrier, sealants, and roofing. We have manufacturers out there that have products that we can use in colder weather, but that will increase the upfront cost of material. And again, it brings us back to budget. So like I said, early on involvement from the contractor kind of ties in the picture. So if we're able to comment on the schedule and budget, we're able to select materials that work on the budget and within our timelines that we're looking at.
That's excellent. But it sounds like the Passive House is pulling on all of our major processes, and like usual, it's all linked, and you follow one complication into the next issue. Are there any further thoughts in terms of understanding the scope of achieving the EnerPHit numbers, Lori?
Scope is definitely very important. Understanding the performance expectations for the project and then how they're actually going to be measured and verified is really the first risk that came to mind when we started reviewing the project. Given the rigorous process for Passive House projects, it's really important that we came up with a plan early on that allowed us to identify what these performance requirements are and how we're actually going to be able to monitor and verify this as the construction process goes on. So for example, understanding the air tightness requirements for the project was the most significant concern I had right at the very beginning of the project. We had to first confirm in our minds that yes, on a project of this scale, are we going to be able to meet this 0.6 air change requirement? Because although we're an EnerPHit project, we are actually being held to the air tightness requirement for a new construction project. So we had to make sure that our construction at the end of the day would meet the 0.6 air changes per hour. So we had to first identify this and then come up with a quality plan that will allow us to confirm as soon as possible that we could in fact achieve those performance requirements on the project.
Excellent. Sounds like we took care of some of our fear factor right away with that. Just the notion of finding out that they're achievable first and then engineering processes that are going to meet that goal. That's incredible. Andrew, anything that you can add from the field side of things in terms of the challenges?
Certainly. So yeah, in addition to some of those comments, I know my perceived risks were, building a trade team to perform something new in the industry, working with those trades. Retrofit, meaning they're working with existing dated structure, which has a lot of unknowns. Removing many major components of the building, like the windows and the balconies, leaving these areas ready to receive new assemblies.
Yeah, you can see that by the time we get down to our trade crews, all the way from where the design started, you've got a smattering of new products, new materials, new assemblies, and all mixed with standard retrofit concerns that always contribute to complexity, whether they be changes or existing conditions. All of these things tend to apply. So that being said, with all these risks coming into view, what steps would we take in terms of mitigating these at the Soble Tower?
So some of the steps I'll touch on. We'll start off with the training of the team. So PCL completed a full day of Passive House introductory training. We also attended a conference on whole building air leakage testing. We also put time towards reviewing Passive House documentation and case studies to get an understanding of that. Review design documents and specifications with our subject matter experts like Lori and yourself, Stephen. And then during that design review, we do that prior to tendering so that we can build a good, carefully coordinated tender documents. And then while doing that, we identify constructability, continuity, and material issues. Also, cost and budget issues. Worked with the project team to identify costs and issues. We also helped to identify additional savings for the team.
Excellent. I mean, that's a lot of planning, and that covers the planned side. Now to get on to the interesting part, what about existing conditions on the retrofit? Did we find anything that threw us for a loop? Was there any of the traditional, oh my, situations where we had to work around it?
Definitely was, especially with Retrofit. So working with the team, we addressed existing conditions. An example stands out to me is early on in the project, we found that the interior walls of the exterior contained mold. These walls were to remain, but due to the new findings, they need to be replaced. So this gave us the opportunity, or the design team, an opportunity to change the envelope. This was great in that it provided a better constructible envelope and ultimately just a better durable product at the end of the day.
All right, Andrew, that is definitely a project moment there. Hindsight tells us that you steamed through the problem without issue, but in the moment, that must have been something significant. Lori, from your position of oversight, how did this discovery affect our plan, and were we able to mitigate it with what you had in your bag of tricks?
Well, the one thing you always have to be prepared at when you work on existing buildings is that you're going to basically expose some conditions that are a surprise. And in this case here, this surprise mold actually turned out to be a blessing in disguise. It was actually a positive. As it can be seen on the details, the original proposal involved the introduction of all new insulation and control layers on the exterior side of the existing masonry. This required the construction of an assembly that really wouldn't commonly be found in most of our construction projects. And this resulted in some apprehension and concern from our trades because they weren't used to building such a massive exterior wall system on the outside of the building. So although it was theoretically possible to construct, there was some concern and some basically people were worried about how they would necessarily get the continuity, the attachment, or the constructability of some of those details. So I wouldn't want to say that we're fortunate to find mold, but it actually allowed us for us to use a much simpler wall system that was able to be constructed by our trade partners using systems that they were very comfortable with using. Foil-faced insulation was installed on the interior side of the existing masonry wall system with a stud wall and drywall, whereas on the exterior side of the wall, we were able to actually install a continuous air barrier as well as the insulation as part of the eaves assembly. This simplicity ultimately allowed for us to create a successful building envelope.
That's great, Lori. It's always good to see unforeseen issues turned into an opportunity for improvement. It sounds like it kind of got all the trades down into the sandbox with bits and pieces that we were going to use to solve these problems, and even made a more solid understanding between everybody about what the plan was going to be. So Andrew, moving back clear of the mold issue, was there anything else that continued to put itself in front of you on your path to project?
Yes, most definitely. Some more steps that we took where we're getting trade interest. So finding a window suppliers, finding installers, finding qualified eaves contractors. A project set up an information presentation. We invited all the trades to attend. And we explained or provided information on the project and a little bit of Passive House to help alleviate some of those concerns that those trades would have at the tendering stage. Also important to advance procurement of windows. So keep that in mind. We definitely want to expedite window mock-ups or multiple window mock-ups. And then set up of window detail workshops with all parties, installers, designers, and suppliers. It's very important.
Well, it really sounds like across the board in everyone's role, envelope is becoming a louder and less of a lonely bit of scope at the tail end of the architectural spec. It's becoming sort of the living, breathing center of it that we have to check and see all the way through how it's being fit together.
To help demonstrate our general sequence, we prepared this model.
And this model basically shows where we've set up our trailers and how the climbers were set up. And during the setup of the climbers, we even did the base building air test.
While setting up the climbers, we ran into a couple constraints with the existing structure, finding some unknowns. We had to do some rework of the climbers.
We made sure to keep the climbers well back to accommodate the variations of the structure and the thickness of the future eaves.
So here you can see we're removing the balconies, the existing balconies on the north and south elevations. At the same time, we are getting set up and started on the east and west elevations.
Yeah, and while that was happening, we were doing the demolition of the interior, where we ran into mold and asbestos abatement on the exterior walls. So we continue with those activities at the same time as the balconies.
Here you can see applying the air barrier over the existing brick and removing the windows and installing plywood in place of the windows to protect the interior finishes while we continued our work on the inside.
And that allowed us to work in the colder months, and applying the air barrier on the brick was actually a benefit to the job and a result of us finding mold on the interior walls.
So over the winter, the fair weather activities had to wait until spring, so we prepped by setting up scaffold on the penthouse and various activities. Spring came, we started installing windows on the east and west elevations.
And as soon as those windows started, we were 2 floors below doing interior tie-ins and making sure that interior work continued.
As we installed the windows, we did our assembly testing as we progressed up the tower.
And as you see here, once the windows were done, we followed through with the eaves finish. While the windows were happening on the north-south, eaves was happening on the east-west elevations. Top, and then roofing continues.
As well, at the same time, we were obviously working on the interior, follow the window installation on the interior. We're moving the scaffold on the penthouse after that eaves system is complete. And that's our final completed project.
Excellent. Sounds like quite the shift actually in terms of looking at a schedule and seeing it arranged section by section by portions of envelope is truly a different approach. But if it's necessary, then that's what's got us there. It's also interesting to see the 3D building model filling an ever increasing role in visualizing this across the various members of the team. It's something that's sort of fitting into the background now, but worthy of mention for sure. So even with all the mitigation that we had, did you encounter any schedule issues? Did we put together a perfect schedule? Or what was the story there?
Definitely ran into some scheduling constraints. Like any project, you definitely I've been on. You have some constraints you need to work around. I'll raise a couple of them. We'll talk about a couple of them here. The first item I'd like to mention is weather and access constraints. This required a high level of coordination. Some of these building envelope products are critical to temperature and cure times. That cannot be substituted out. So examples are our eave systems and our roofing systems for this project. So these systems, we could not install them when the temperatures are around 0 degrees Celsius, or if it's moisture, if there's moisture in the air. So definitely had to incorporate that very closely.
And if you're waiting for windows, I imagine that's going to be a problem too. So windows and getting closed up is probably another concern that comes right on the tail of that.
Definitely, yeah, definitely. So speaking of windows, definitely had some constraints on our windows. So some of those would be including shipping across Canada, procurement of specialty custom components. With these windows, they are usually custom to these types of projects. So it's important to identify these early. Follow up regularly, keep in touch. If possible, in some scenarios, you can have the components sent directly to site to alleviate that one step, sending it to the fabricator.
All right, so definitely need some supply chain involvement in there in the early stages. And I guess COVID, the pandemic realities there would have played into your role as well.
Interesting you say that. COVID-19 is definitely another challenge that we had. So it became a reality halfway through the project when it mandated additional measures that we had to implement. We combated that with adding additional labor to implement some of those measures. We offset trade start times. We extended work hours. We assisted trades in supplying the mandatory PPE, and we worked on trying to spread out the work activities.
So we got weather, we've got new products, we've got pandemics. It sounds like for schedule, we were run through the ringer on this one. So again, congratulations on getting through that. But what about design changes? Was there anything in the design that wasn't just right, that needed to be tailored as you went?
So interesting you speak of that. One last challenge I'll talk about here is regarding significant design change. So example we spoke about earlier is the envelope changing. So the process of completing that change is pretty significant and time consuming. There's a large process of reviews and modeling approvals in various entities. So you really want to take those in consideration and identify those early on.
Okay, so there's no shortage of scheduling challenges, but again, the early design consideration and interaction got around to that and sort of reinforced our fundamentals towards success. Lori, going back to the 4 envelope principles, I know there's 5, but the envelope principles in particular, can you run us through any of the Passive House principles that really challenged us or altered our typical plan?
Sure.
For Ken Sobel?
There's actually, as you mentioned, there's 5 fundamental principles for the Passive House, 4 of which pertain to the building envelope. For the Ken Sobel project, the main objectives, we were able to achieve them by doing the following. First and foremost, by having a high level of insulation present on our opaque wall systems and roof systems. As it can be seen by the details, 152 millimeters of mineral wool insulation was installed on the exterior face of the existing masonry walls as part of the eave system. An additional 100 millimeters of foil-faced mineral wool insulation was added to the interior surface of the wall behind the drywall. This resulted in the U value of the opaque wall areas to be approximately 0.13 watts per meter squared Kelvin. Pretty impressive. Yeah. The new roof system consisted of 400 millimeters of insulation. Installed in an inverted configuration, which resulted in a U value of approximately 0.074 watts per meter squared Kelvin. Very high performing roof system. Absolutely. The next requirement we have to look at was the having well insulated glazing assemblies. As it can be seen by the detail, we used triple glazed Cascadia fiberglass windows. This provided us with a U value of approximately 1 watts per meter squared Kelvin. Very high performing windows, and they are Passive House certified. After that, we had to provide a design that was thermal bridge free, and we had to construct it without having any of the thermal bridges present. We achieved this by removing all of the balconies that were present on the building. We installed fiberglass support angles for all the window systems because they were slightly moved exterior from the original openings. And we used PVC through-wall flashings throughout the building. So now on to airtightness. A continuous air barrier was installed in all the surfaces of the building envelope. This was necessary in order for us to achieve the 0.6 air changes per hour requirement of Passive House. A cementitious air barrier was installed behind the eaves cladding system to form the air barrier on the opaque wall surfaces. A silicone transition sheet was used to create the continuity from the opaque wall surfaces to the fiberglass windows. The new waterproofing on the foundation walls, as well as the roof membranes, all tied continuously into the exterior wall air barrier system provided by the eaves. Although the penetrations to the building envelope were minimized as part of the design process, extra care was taken on the penetrations that did exist to make sure that we got continuity at every single location. So we undertook a very detailed quality program that began at the very beginning of the design phase and continued on throughout the entire construction process, which enabled us to monitor and confirm the performance of the building envelope system. One of the main components that Andrew's mentioned earlier was the testing program that we implemented on the project. This involved a number of tests from the penetration perspective, using, for example, bubble tests, the penetrations to make sure that they're well sealed, as well as performing assembly level tests, a guarded floor test, as well as a whole building air leakage testing on the project. So now that I've talked about the 4 building envelope related to the principles, I'd like to ask you, Stephen, how do the mechanical systems meet the need for the ventilation with highly efficient energy and heat recovery?
Well, with Passive House, if energy is consumed, it's got to be accounted for, and if it transfers across the envelope, it needs to be fully accounted for. The Soble Tower recovers energy whenever it crosses the envelope. For the ventilation side, the air side, those are fairly standard things that we see much of, like our ERV units, energy recovery ventilators, and air side heat recovery. But Passive House goes a little bit deeper to the point where, just as 2 examples, wastewater is on its way out, is going through a coil past incoming domestic water. That's giving a little bit of heat to the incoming water and taking out any heat that we've added to that drainage water on its way out. So again, Passive House just goes that extra step further. And up on the roof where you have vents that typically on a building are leaking air 24/7 to the atmosphere, we have those capped, and they're only opening when there's enough pressure in the plumbing system to justify opening them. So again, just this incremental drawdown of the energy that we use within the building. No amount of energy is left ignored. And for me, that's just it's a great way for the industry to get back to drawing our envelope as a thermodynamic barrier and remembering that everything that crosses it is carrying energy in and out. So that level of review can't help but start finding the kinds of savings that we see with Passive House projects. But I'm at risk of going off in a mechanical direction that I didn't intend to go off on. Let's get back to the air leakage mitigation techniques. Lori, what measures were taken in our air quality program so that we get that incremental measured performance as we went?
It was identified right at the beginning of the project that air leakage would be a risk that would need to be very carefully monitored and coordinated. Achieving the 0.6 air change requirement was an essential part of the construction process. After completing a detailed review of all the building envelope details and design, we wanted to make sure that we actually could build this building to meet this 0.6 air change requirement. So we actually retained the services of a consulting engineering firm and asked them to go through a detailed study by taking off every single assembly that was present, all the transitions, all the penetrations, and come up with a model for us that would help confirm whether or not we could achieve these goals. They quickly assembled this model for us and came up with an overall estimated air leakage rate based on typical industry standards, which suggested that we would be able to build this building to achieve approximately an air tightness of 0.41 air changes per hour, using, as I mentioned, standard industry values for air tightness. So as it can be seen by this chart here, you can see that we have actually been able to get some sort of confirmation that the goal for achieving the 0.6 was well within our grasp.
That's excellent. It sounds like you really managed to push the conversation. That's not always easy to have. I mean, we did bring in another consultant, but definitely a good idea to get that conversation up front, a critical one for sure. Where did we go from there once we had that all nailed down and we were sure we could make it?
Yeah. So once we were assured we could actually build this project and meet those goals, we then developed a very comprehensive quality control program. It included review of the submittals to make sure that we got material compatibility and adhesion. We also were looking at it from a continuity perspective and a constructability perspective. We also looked into doing first installation reviews and mock-ups. We also had very periodic visual reviews throughout the entire process. A key part of this program, as I mentioned previously, was the actual testing of our materials and systems on the project. We actually developed an alternative approach as a result of the change in the construction schedule that Andrew mentioned earlier. By having to go face elevation by elevation, we were not able to do the guarded floor tests as it originally had been proposed by the architectural team. So we came up with a very comprehensive program to be able to take the information obtained by assembly level tests of the windows and the transitions to the systems around it to be able to confirm that as we install these systems, we were indeed meeting the goals for our project by taking this information and putting back into our air leakage model that we had created earlier on. This allowed us to confirm that as we were building it, while we had access to those transitions, we were meeting the proposed targets. We also then completed one guarded floor test partway through the process, just to verify that yes, if we looked at the entire floor, we still were meeting the goals. And then at the end of the day, we ended up completing a whole building air leakage test as well. I'd also like to mention that in addition to air leakage testing, we also undertook several other water penetration tests of the window systems as well, because that is a very important part of building envelope performance, and it represents a very significant risk on our projects.
Excellent. So testing sounds like it was seen as a necessary risk, and no doubt it was not a small conversation to get everyone along the line to understand what their role was going to be, what their costs were going to be, and what maybe might slow them down with this additional process in their day-to-day. So I like that. That sounds like there was a lot of planning involved in that. Very good summary, though. All right, Andrew, what did this look like on your end for site? What was it that we had to do to meet the air tightness requirement?
So there definitely was a lot of things we were considering and monitoring. I'll start off with Passive House trade contractor training. So we implemented a training session for the trades where we brought in a Passive House consultant to review or to provide a review to the trades of overview of Passive House. And also they provide specific details of our project to the trades. This provided an excellent basis for the trades to understand, identify unique design elements that they may encounter during the project. We also completed a detailed submittal review working session with all parties. Very important to get all parties involved.
And what did those look like in terms of just the atmosphere? Who was involved?
It was excellent. It was a team kind of building scenario. We had the contractor involved, the suppliers involved, design team, and obviously ourselves. And it was kind of just a work together session. Worked really well. It circumvented a lot of emails and different submittal scenarios, so definitely recommend that again. We also had first install review mockups. This involves getting consultants, manufacturers, contractors on site to review first installs and key assemblies.
Sorry, Andrew, I just wanted to jump in here to emphasize the importance of this first install reviews. Not only just on Passive House projects, but all of our projects, first installation reviews are a key part of our quality programs because it allows us to get all the important team members present, including the architect, the consultant team, as well as the suppliers, the manufacturers, the installers. Everybody comes together to review the initial assembly at a point in time prior to installing these systems in bulk on our project. This allows us to identify any concerns or any issues at a time that allows us to continue on with this construction without the need of having to do a significant amount of rework. Could you imagine identifying a deficiency after you've already installed 25, 30, 40 windows in your project? It's really important that we do these first install reviews right at the beginning to make sure if there's any changes necessary, that we can implement them in a timely fashion to minimize rework. And so, sorry, I'll hand it back to you, Andrew.
Yeah, thank you. Exactly, Laurie. Definitely very important. Other air tightness items that we considered that I'll bring up today is identifying areas that need to be mocked up. We need to schedule these and schedule them early on to help relieve any possible impacts that they may create. We need to review all aspects of these installs with suppliers, manufacturers, installers. It's very important to have the team involved that'll be involved in building that or putting it together. We also implemented PCL's and subcontractors' quality review programs. This included checklists throughout all installations, documentation and logs maintained, and implementation of AirBoss role on the project, which assisted with all those items. Another one was detailed continual coordination with the trades throughout the project. This included a daily detailed meeting and follow-ups throughout the day, and then collecting of documentation and weekly scheduled meetings.
Again, the lists are quite extensive and concise, but it sounds like a lot of planning. So, well done. We've dropped the term a number of times. AirBoss. What does it mean in the Passive House realm, and how does it change your life?
I knew you were going to ask that, Stephen. I took on the role of AirBoss, a career first for me, and I would say for most. This tied the design, the consultants, the trades, even the testing companies together to become a synergized unit This, for our project, achieved better than anticipated results. The definition of air boss to me is someone who is on the project that takes the lead of the envelope, and specifically the air barrier. This is also someone who manages and is part of the installation, including the mock-ups, including scheduling of scopes, sequencing, trade quality programs and PCL programs, and scheduling the inspections and testing, and then just day-to-day supervisory role. It's important to identify someone who will be lead. This will assist in limiting miscommunications, provide clear and consistent communications, and expectations that are out there. On larger projects like this one, there will be assistance from others to support you with some of these aspects.
Although not a job typically completed by a contractor, I just wanted to reinforce that the air boss role is an essential part of our quality program. It's best suited to be completed by a general contractor, in my opinion, as we have the responsibility to define the scopes, prepare the schedule, and the sequencing of the work, as well as to monitor the budget and undertake the quality review process. The superintendent, in my opinion, ultimately controls the day-to-day activities of all the subcontractors and is in the best position to be able to complete the role as the air boss. As evidenced by our results, Andrew did an outstanding job as the air boss on this project.
Very much agreed, Lori, and very well done, Andrew. But you mentioned results. Why don't we indulge a little bit and talk about the testing and quality reviews that we had before we get into the success. How did all these impacts and tests, how did they impact your day-to-day?
There's definitely a lot of considerations need to be taken depending on your testing plan. You need to understand access requirements and the sequence of the preliminary all the testing. You need to know that early on so that you can plan for it and put it into your schedule. These testing elements are time-consuming and labor-intensive. Their high elevations especially add an element to it too. Considerations and durations of manpower need to be worked into the sequence as well. Some of the examples from our project was 4 trained workers required to operate a double mast climber. We required 4 workers to install and remove the large window enclosures for testing. What this did is eliminate access to other trades to that elevation for multiple days while they're setting up the enclosure, testing, and then removing the enclosure. Then also, high elevations are affected more by weather, causing more weather impacts, including limitations of testing equipment. So some testing equipment has some additional limitations that some people may not be aware of.
Yeah, you can certainly see how, with no early plan, you wouldn't have had the eyes and ears of your team tuned to catch all of these multiple mitigation techniques that you'd introduce by going through the design and execution incrementally. So really, really well done there. So in theory, with no plan, we would not have trained eyes and ears on site. Testing dates would fall victim to the realities of weather, limited access, and the other standard planning problems that we've been talking about. So Jonathan, on your side of things, were there any pieces of technology or new tricks that we employed to make this all happen?
A passive house project doesn't require any high-tech technology or complex systems. From what's available out in the market today, it would be nice to have some at your disposal, but with a tight budget and tight schedule, we were able to do this job relatively focusing on the fundamentals with good practices, good planning, and coordination.
Excellent. So at the core of it, Passive House is achievable by sticking to fundamentals, but the introduction of technology obviously makes us stronger, faster, and capable of handling more. That's good news. Thank you. All right, then let's move on to end results and what we ended up achieving against the Passive House standard. What was the result for the team, and how did we do against the metrics?
I'm very happy and proud of our project team. As you may recall, at the beginning of our presentation, I mentioned that we retained the services of a building envelope consultant to help us come up with an air model for our project that would predict our estimated air leakage rate based on current industry standards and practices. That number that they predicted was approximately 0.41 air changes per hour. At the end of our project, the final operational whole building air tightness test revealed that we had an air change rate of, wait for it, 0.235. well under the 0.6 air change requirement for the project and almost half of what was predicted. We undertook an infrared review during the pressurization and depressurization testing for the whole building air leakage test, and I'm very happy to share some of these images to show that no anomalies were generally identified in our building envelope system. Excellent. Our thorough quality control plan and our efforts of our project team were very successful. Great job, team.
That's truly a great feat for our company, guys. Thank you. Let's open up the table for last takeaways. Jonathan, do you want to just wrap up what your thoughts were?
Get in early. As a contractor, consultant, or owner, you want the team to come together as early as possible. Having a contractor provide input in the constructability, schedule, and budget early in design stage is a benefit to the project. I would say also create a team atmosphere. Everyone has a role to play and they have a responsibility to be held to. Create goals and address the concerns of the team while holding everyone accountable to those goals. And I would say educate the team. As Andrew mentioned previously, this means educating them on their responsibilities. It's still a new model for a lot of our trade partners and experience is limited. But having that training session really gave everyone an insight on what Passive House means and gave them a more detailed understanding of how it affects their scope and our jobs.
Excellent. Andrew, last thoughts?
Yeah, for me, possibly just reiterating what we've said before, but building a quality program around the high performance envelope requirements. It needs to be detailed with a hyper inspection documentation program in place for all parties. So not just the general contractor, but the trade contractor, inspection agencies as well, and even the consultants. We need to consider sufficient forces, obviously, to implement this as well. And then mock-ups. So definitely a very important one, first installs or mock-ups. Considerations need to be early, and you may have to do multiple mock-ups as well. This will assist in reviewing and making any adjustments early on before we order all the windows and build the entire project. And you also want to complete testing on that mock-up or first install of the window. Yeah, and then mock-ups and first install reviews, very important. I think it worked well on this project to have everybody involved in that review. So the same message is getting conveyed to everybody at the same time.
Great. And Lori, you want to bring it all back home?
In addition to the evolution of our codes and standards, owners and society are demanding that building envelopes become high performing. And they're also actually demanding that we measure and verify that our building envelopes that we actually build meet these requirements. In my opinion, as I mentioned earlier, this change should become best practice, and we as contractors should be able to meet this challenge not only on Passive House projects, but all of our projects moving forward. The Soble Tower demonstrates that high performance is possible on large-scale tower retrofit projects. And I think, in my opinion, we are ready to implement these construction practices and the quality activities from this project on all of our projects moving forward.
Yes, and this is kind of the repeated point coming out of many of these low-carbon, high-performance programs facing our industry. These projects are achievable, but they absolutely require the kind of teamwork and communication that we've been talking about in the industry for years with regard to integrated project delivery. The IEA, International Energy Agency, posted in 2019 that was our biggest year for carbon dioxide production from buildings ever. So as much as we're improving new construction and making new buildings wonderful, we're still making more buildings. And not until we turn our eyes to the existing building stock and with our clients go at these buildings with the kind of planning that we talked about today, are we going to get the kind of carbon reduction that we need to meet our national requirements. So if PCL can show clients projects like the Soble Tower that can be performed now, then we're really getting to that point where we can start marching towards our goals the way we need to. And that's just a job well done. It's an exciting moment for the industry as a whole to be able to say that, yes, that's a high goal to achieve, and yes, we can achieve it. So that about wraps up our program discussion for today. Let's move on to the Q&A.